My name is Uttam Dwivedi. I work as a team lead for the smart construction project at Ando Hazama Corporation. This is a bit weird. Sorry. And I'm also doing my PhD from the University of Tokyo, Japan. Today, I will talk about the real-time safety analysis system that we developed for some other companies that are kind of analyzing the damages done in a conveyor belt. Let's start about me. I did my BTech from IIT Kanpur in India in 2016, and then I went to do my master's in remote sensing from the University of Tokyo. After that, I joined Ando Hazama Corporation, and I'm currently working there. So one of the main places where we use conveyor belts are in the field of like tunneling, especially using NATM. So the problem with the construction industry in general, especially with the machine learning, is they're very slow to adopt the machine learning technologies. They have very legit reasons as well, actually. As some of you already presented, especially in the robot use cases, we have a very frequently moving job locations. So if you have some sort of a robot or some sort of cameras that you are placing in the construction industry, you need to change it very frequently. Then it's very dangerous location because we use explosives and the air quality and everything, especially in the tunnel area. It's kind of like that. And then the integration part, the main problem with the integration is the limited data availability. So for example, I'm not sure if you can see it very clearly. This is like a tunnel under construction, and we have a blasting going on here. So sorry, it doesn't play. Yeah, okay. So basically you can see like the amount of smoke and everything that's coming out. It's very loud as well, but I have turned off the volume. So the idea here is like after you have done the blasting, you need to move all the mucks, all the like these waste out of the tunnel to start the construction. And in this process, it's okay. Yeah, so this is how we do the blasting. Basically, we put dynamites in the like on the walls of the tunnel, and then like these charges basically gets activated after like doing all the safety checks. Sorry, this is a long video. Let's just skip it. So yeah, this is kind of like the idea. Once you are done with the blasting, then you do the excavation of muck. So you have basically multiple different steps, and we have basically developed machine learning algorithms that can detect these different steps. But unfortunately, they are not the part of this presentation. Here, we are mostly focused on the long conveyor belt part. So basically, here you have it's kind of moving rather slowly. It's carrying out some of the birds and things out of the tunnel, and the real speed kind of looks like so one of the machine learning models that we have kind of identifies if we stop if there is like some sort of a stoppage that will stop the flow of these mucks. The second part is basically we are if there are like some damages basically in the belt. So the steps are actually the machine learning part is rather simple. The first step is basically we detect and track the damages. And the second part is we identify where those damages are, because generally these are very long belts. They are somewhere around like 1 kilometer to 2 kilometers, like kind of areas. So it's not easy to just do the human inspection. And you already saw the environment that these construction job sites are. So it's very difficult for like a human to intervene all the time and do some sort of checkup. So we simply divide the problem statement into these 3 steps. Here, the third step is rather tricky because we need to do all these things in real time. So to develop, to be able to develop this kind of solution that can run like multiple cameras, maybe like 12, 13 cameras in real time. That's rather challenging. And in my understanding, actually, that's a bit more challenging than the step 1 and step 2. So our setup kind of looks like this. We have like a camera and some lights because it's very dark inside. And then we have the edge device, or in some cases, we also have the cloud servers as well that detects like damages, and we classify those damages into 4 categories. Through damages, that's kind of like going through like large big damages, and then we have large size damages that are not going through. So it's not like crossing on the other side of the conveyor belt. Then we have like a medium sized damage and small size damage as well. So the development process for the machine learning was rather straightforward. First step was data preparation. So we simply just collected a lot of images from the construction site, and then we divided it into 11 classes. The first class is basically the damage, the crack itself, and then we are detecting the numbers between 0 to 9 because there are markings done on the conveyor belt at every meter. So by identifying these markers, we can identify at what length or at what distance the damages are getting done. Then we simply apply like this was done almost like 2 years ago. So we used YOLO V4 at this time. Right now we have like using the system in around 10 construction sites, and we are using like another YOLO models basically. Okay, so this is kind of like the interesting part, the deployment flow part. So basically we use like some sort of optimizer basically that optimizes our model, so that let's assume like before it was performing somewhere like 1 frame per second. By using this kind of optimization technique, we can make it perform 10 frames per second with almost similar sort of accuracy. And this can be done for multiple cameras at once. So this is like really interesting part basically. So this is the result. You can see the markers like here. So these are the numbers that we are detecting. These are happening at like every meter. And then like this is, for example, the example of like through damage. Then we have some small damages and large size damages as well. The accuracy was like fairly good, especially for like through damage. It was really good. Medium, there were some misclassification done for the medium and small size damage because some were misclassified into small, or some were like some mediums were misclassified into small and some smalls were misclassified into medium. But overall, the damage detection model was good enough, and of course the number detection model was fairly simple and it was really accurate. So in conclusion, we developed a model that we're currently using in around 10 construction sites, and it provided an overall accuracy of 99% basically. And we can identify the small like different types of damage, and that kind of identifies to the construction engineers what kind of action that is supposed to be taken with respect to the damage. For example, if it's a through damage, then they have to stop the entire process immediately. And if it's a different type of damage, then like they can run the machine slowly, or they can basically do not care about it at all. So that's all from my side. Thank you.